Alright, in this video we're going to be talking about metamorphic rocks. Please get your rocks flowcharts ready so we can fill in our final third column. Now, recall, rocks are classified according to how they form. Igneous form from cooling and solidified magma. Sedimentary form from compacted and cemented sediments. And now our metamorphic rocks, these are ones that are going to undergo some sort of change, a metamorphosis. And what drives that change is exposure to heat, really intense heat, or pressure, intense pressure. So metamorphic rocks are rocks that are changed as a result of exposure to intense heat and or pressure. So there are two types of metamorphism that occur in nature. And the first type is called contact metamorphism, and the second is called regional metamorphism. So let's talk a little bit about the difference between these two. Now, imagine you have the surface of the earth here, and you can see some trees, and these colors here, these are layers of rock underground. And so I'm going to show you how contact metamorphism works. The reason it's called contact is because it involves existing rocks coming into contact with really intense heat, which is generally provided by lava or magma. So imagine that one day an intrusion of magma forces its way up through these layers of rock. Now, all of the existing rock are going to be burned by the heat of the magma. So all along the edge of this magma, shown here in orange, you're going to have rocks that have been burned by the heat of the magma. That burning causes them to change or metamorphosize into something new. So anywhere you see the orange, you're going to have some metamorphic rock. This is caused primarily by heat. Let's fill this in on our flowchart. Okay, so the first type is contact metamorphism, and this is caused by contact with heat. Whenever a rock comes into contact with magma or lava, it is burned or metamorphosized by that heat. But let's talk about the second type, regional metamorphism. Now this one is going to be more from pressure. So let's imagine that I have a plate boundary here, a fault, a crack, and that these two plates are coming together. So it's a convergent plate boundary. Well, as you can imagine, in the middle here, there's going to be immense pressure, and that pressure can cause the rocks trapped in the middle to become metamorphosized. So all along this boundary, you'll find metamorphic rocks. Again, this is different from contact in that it's not so much about the heat, it's more about the pressure. Let's take a look at what we see here. This is a typical progression of metamorphism that occurs, starting with the sedimentary rock shale. If you add heat and pressure, it will metamorphosize to slate. If you add more heat and pressure, it will become phyllite, more, and it will become schist, even more, and it will become the metamorphic rock gneiss. Take a look at that gneiss sample down there. You'll notice it has bands of minerals. That's a result of the intense pressure. Now, if you were to take gneiss and add additional heat and pressure, it would likely melt into magma or lava, and then it would become an igneous rock. So gneiss is generally the extent of metamorphism that we see. Let's go back to our flowchart. So our second type of metamorphism is called regional metamorphism, and this is caused primarily by pressure. Of course, all of this is summarized in your reference tables on the metamorphic rock chart on page 7. You'll notice type of metamorphism, composition, what minerals are involved, how big the crystals are, whether it has banding or not, the names of the rock, and the map symbols. And of course, we'll learn lots more about this chart in detail in the coming days. Thanks for listening.